JMath.
Let's look at each one of those sums we just did in that quick overview, but let's slow it down a lot so that you really know what's going on and how to use these rules. So in the previous video, I said you are always going to get 3 pieces of information for every triangle. Now, if that combination is a side and an angle that goes together, so in this one on the left, I know the purple side and the purple angle. Then I know the orange angle, and they are asking me for the orange side. So if I have a couple and one other angle, I will definitely use the sine rule. So my rule is always start with what you want. I can see I want side A, and I have the angle, so I'm going to say sine 52.38 is what I have. Then I also have the purple angle and side. So because I started with side A, I am going to start with side B on top, and that is 5.74 over sine of 80.98. Great. There I used the sine rule. I don't need to write a reason, it's not Euclidean geometry. And now I can just type that in the calculator and get the answer. So in this case, I will have to use my algebra skills and see A is going to stay where it is, but I'm going to multiply this sine 52.38 over to the other side, and the purple things are just going to stay where it is, 5.74, and that's all over sine 80.98. Now I can just type it in the calculator and find the correct answer. And my calculator tells me this answer is 4.60, and normally I just round off to 2 places, so that is the answer. They didn't give me any units, so I don't know if it's meter or centimeter, so I'm just going to write the word unit. I was looking for a side, and therefore I put the small a and the small b on top, and the sine with the angle at the bottom. Let's look at the one on the right, which switches, and I'm looking for an angle. So I'm going to start with sine of alpha up top, and I know the orange one goes with 5.61. On the other side this time, I know the blue values, so I'm going to say sine 49.62 over 4.31. So please, if you start with the sine of an angle, the other one also needs to have the sine on top. Now I can just half cross multiply the 5.61 over to the other side, type it in the calculator, and then find the answer. But because I'm working out sine alpha, I know I'm only going to get the value of alpha if I shift sign the decimal. Now, if I type in this entire decimal, my calculator tells me it is 0.991531. Please don't round off that number. Use it on your calculator with the answer button and say, therefore, alpha is going to be shift sign of that entire answer, and it says it's 82.54 degrees. So now you can round off to 2 places because it was the actual question. A big important rule with sine rule and cos rule, never round off until it is your final answer. This is extremely specific, and if you make a rounding error, your final answer is going to be 1 or 2 degrees off, and you're not even going to realize it until you see that red cross on your test. Let's analyze these 2 triangles. Now you can see the heading says the cos rule, but how do I know it's not the sine rule? So I highlighted everything, and I can clearly see I am looking for the orange side, and I have the orange angle, the beta. But I don't know any other angles, and therefore I have no couples in this question. So I have the blue side, I have the purple side, but I don't have the angles, and I have the orange angle, but I don't know its side. That is the recipe for cos rule, because it has 2 sides and the included angle. Okay, guys, so luckily you get this on a formula sheet, but the rule is if I'm going to use beta as my angle, I need to start with its opposite side. So I have to start with b squared in this case. Then the other 2, the order really doesn't matter. So I can say 3.54 squared plus 3.77 squared, and then minus 2 times 3.54 times 3.77, and then cos of 72.21. So it's massive to write down, but luckily now I can just type that whole thing in my calculator and get the answer in one shot. So I'm looking for b and not b squared, so I know I'm going to use the square root, and if I type in that entire line on my calculator, it tells me it is going to be 18.589 and lots of decimals. So I'm just going to keep the answer value on my calculator and just say square root the answer, and therefore the answer is 4.31 units. Once again, do not round off before it's your final answer. Otherwise, you are going to make a mistake. So the classic case for cos rule is 2 sides and an included angle, but this one on the right, I don't have any angles. I'm actually looking for an angle. So in this case, I need to, again, use the cos rule because I can't use sine if I don't have any angles. But I can use cos rule if I have 3 sides and I want to work out a specific angle. Now, what's extremely important is I want to work out angle A or angle alpha, and therefore I must start this whole equation with side A. The other 2 don't matter the order, but the one that is opposite to the angle I'm going to get must start this whole equation. When you get to this part of the sum, you now have a choice. You can go and type in all the values separately and write it all down. I would very much prefer to type in the calculator once and get the answer. So I'm going to move the two squares. I'm going to move left. I'm just going to subtract it on the other side. And then I'm going to divide by the -2 and those two brackets so that I can have something is equal to cos alpha. Please practice this one a lot so that you can get used to what stays on the right and what moves left, because there's a big spot where you can lose marks if you didn't practice enough. Now I can just type in all of that in one shot in my calculator, and the calculator tells me this is 0.46887, and then it just continues on. And if I shift cos, I get an answer of 62.04 degrees. So please remember your degree sign. Don't write units next to it. It's degrees. Now we get to the area rule, and this one is luckily very easy. You only use it if they ask for the area or if they give you the area. So you don't see this very often. I had to look very far in past exams to find an area question, but it is on your formula sheet and you need to know how to use it. Now this, even though there's a sign, the setup is exactly the same as the cos rule. I need two sides and the included angle in order to use the area rule. So the one on the left is textbook, what they're going to give you, and I can then just fill in. So I know I'm going to use sine beta in this case. So the half BC represents the 3.54, the purple side, and the 3.77, the orange side. I can now just fill it in, type it in a calculator, and that is the area of this triangle. Because it's area, I need to remember to use units squared. And that's it, guys. One of the easiest ones, and they really can't hide it. If they want the area, they need to tell you they want the area. The other case where I can use the area rule, and this really doesn't happen often, is when they give you the area and you need to work out either a side or an angle. In this case, once again, area rule works with two sides and the included angle. I can get angle alpha if I use the blue and the purple side in the formula. So let's fill it in and see how it looks. If I just take the 6 divided by the right-hand side, I get a value of 0.8956, and then dot, dot, dot. And therefore, alpha, I would get if I shift sign that value, and that gives me 63.59 degrees. Perfect. That is how you would use the area rule. Now, there are certain questions where they overcomplicate this, and you need to consider, is this maybe an obtuse angle? In this question, that's not what they want. I can clearly see that's not an obtuse angle. But if you get a sum where you don't know if that angle is bigger or smaller than 90 degrees, just take the answer you have and then say 180 minus your answer. So just like general solution in the second quadrant, sometimes if I use shift sign of alpha, then it can be in the first or the second quadrant. So just double check there, but it really doesn't happen often. Great. That was how to use the sine rule, and area rule, and the cos rule. But that was very basic. So what you would see in exams are 2 or 3 triangles together, or they make it 3D, and you need to keep your head about what's going on. In the next video, we're going to do a few of those.
If this video helped you, please like and subscribe.
JMath.